On March 28, 1979, the world watched in fear as events unfolded at the 3 Mile Island nuclear generating station near Harrisburg, Pennsylvania. What began as a seemingly minor mechanical issue cascaded into the most serious nuclear accident in US history. The 3 Mile Island Unit 2 reactor, known as TMI-2, experienced a partial meltdown, forever changing the landscape of nuclear energy. While not as catastrophic as Chernobyl, the incident at 3 Mile Island exposed vulnerabilities in reactor design, operator training, and emergency response protocols. The accident sent shockwaves through the nation and the world, raising profound questions about the safety and viability of nuclear power. The incident began with a seemingly innocuous blockage in a condensate polisher, a component responsible for filtering water used in the plant's secondary cooling system. This blockage, combined with a series of mechanical failures and human errors, set off a chain reaction that quickly escalated into a crisis. Operators, faced with confusing and contradictory instrument readings, struggled to understand the unfolding situation. The reactor, starved of coolant, began to overheat rapidly. As temperatures and pressure soared inside the reactor core, a pilot-operated relief valve designed to release excess pressure opened as intended. However, the valve malfunctioned and failed to close, allowing vital coolant to escape. The loss of coolant, known as a loss of coolant accident or LOCA, is a critical scenario in any nuclear reactor. Without adequate coolant, the nuclear fission reaction, which generates immense heat, cannot be controlled. In the case of TMI-2, the malfunctioning relief valve and the subsequent operator errors exacerbated the LOCA, leading to a partial meltdown of the reactor core. As the core overheated, the zirconium alloy cladding encasing the uranium fuel pellets began to react with the surrounding steam. This reaction produced hydrogen gas, which accumulated within the reactor vessel. The buildup of hydrogen posed a significant explosion risk. To alleviate the pressure, operators vented some of the gas into the containment building, a structure designed to contain radioactive material in the event of an accident. Although the containment structure performed as intended, preventing a catastrophic release of radiation, a small amount of radioactive gases, including xenon, krypton, and iodine-131, escaped into the atmosphere. The release, while relatively minor, sparked widespread fear and uncertainty. The incident at 3 Mile Island prompted a swift and massive response from local, state, and federal agencies. The Nuclear Regulatory Commission, NRC, the agency responsible for overseeing the safety of civilian nuclear power plants, dispatched inspectors to the site to assess the situation and coordinate the response. Pennsylvania Governor Dick Thornburgh, acting on the advice of the NRC, issued a precautionary evacuation order for pregnant women and young children living within a 5-mile radius of the plant. This evacuation, while intended to minimize potential exposure to radiation, added to the growing sense of panic and confusion. In the days and weeks that followed, the accident at 3 Mile Island dominated headlines worldwide. The incident fueled public anxieties about the safety of nuclear power, leading to protests, lawsuits, and increased scrutiny of the nuclear industry. The 3 Mile Island accident, though not directly causing any fatalities, had a profound and lasting impact on the nuclear power industry. The incident exposed critical flaws in reactor design, operator training, and emergency response protocols. In response to the accident, the NRC implemented sweeping reforms aimed at improving the safety and reliability of nuclear power plants. These reforms included enhanced operator training, stricter safety regulations, improved reactor designs, and more robust emergency response plans. The accident also led to a significant decline in public support for nuclear power. In the wake of 3 Mile Island, many planned nuclear power plants were cancelled, and no new reactors were ordered in the United States for decades. The legacy of 3 Mile Island serves as a stark reminder of the potential consequences of nuclear accidents. The incident underscored the need for rigorous safety protocols, robust regulatory oversight, and a commitment to transparency and accountability in the nuclear industry. The lessons learned from 3 Mile Island continue to shape the global nuclear energy landscape, driving ongoing efforts to enhance reactor safety, improve emergency preparedness, and regain public trust in this powerful but potentially dangerous technology.